Hello my dear student, very good morning. Welcome back to your solution chapter. In this session you have to study the colligative properties. Clear? Colligative property is a properties of a solutions. Clear? What is mean by an colligative properties? This is very simple. Properties of solutions is depends on number of solute particles. Number of solute particles mean what? Number of moles or molecules or ions. The properties of solution depends on number of solute particle means the number of solute means either moles or molecules or ions. Depends on number of solute particles and independent of nature of, that's very important, and independent of nature of solute particles, and independent of nature of a solute particles. Clear? That is your colligative properties means the properties of solution is depends on the number of solute particles and independent of the nature of solute. Suppose you have to add the solute urea, glucose and sugar, whatever it may be. It's independent of its nature. It depends on what? The number of your solute particles. How many moles you have to add it, how many molecules and how many ions, but you have to independent which is solute you have to add it. Clear? You have to depends on number of solute particle means colligative properties. Clear? The colligative property, there are 4 types. Clear? Types of colligative property, there are 4 types. First one, relative lowering of vapor pressure. It is written as RLVP means the relative lowering of vapor pressure. And second, the colligative property elevation in boiling point. And third, colligative property depression in freezing point. And fourth, colligative property osmotic pressure. Elevation in boiling point, depression in freezing point, osmotic pressure and relative lowering of vapor pressure. There are 4 types of your colligative property. These properties depends only on the number of solute particles and independent of your nature of solute particles. Let us consider first what is mean by relative lowering of vapor pressure. Let us discuss one by one. Very first is a relative lowering of vapor pressure. You already know that lowering of vapor pressure, when you have to lowering the vapor pressure by adding what? Non-volatile solute. Clear? You already know that the vapor pressure of a solution containing the non-volatile solute is always less than the vapor pressure of the pure solvents. Lowering of vapor pressure you have to study P0 P naught minus P. Suppose sometimes you require say P naught A and PA, whatever it may be, no doubt. P naught indicates what? Vapor pressure of the pure solvent or vapor pressure of the pure component. P indicates what? Vapor pressure of the solution is called lowering of vapor pressure. But with respect to what? The vapor pressure of the pure component. Clear? This is in the ratio of A by B, clear? Relative lowering of vapor pressure is what? Relative lowering of vapor pressure is the ratio of vapor pressure of the solution. P naught minus P, vapor pressure of the solution. And P naught indicates what? Vapor pressure of pure solvent. Vapor pressure of the pure solvent. Hence, the relative lowering of vapor pressure is the ratio of the vapor pressure of the solution upon the vapor pressure of the pure solvent. This is called relative lowering of vapor pressure with respect to how much is and lowering of vapor pressure. And another important point, relative lowering of vapor pressure is a colligative property, but the lowering of vapor pressure is not a colligative property. That's very important. Clear? The relative lowering of vapor pressure is equal to mole fraction of solute. Next, P naught minus P divided by P naught. Mole fraction of solute means what? Number of moles of a solute, suppose taken as N1 is equal to number of moles of solvent, and N2 number of moles of solute. Number of moles of solute, hence the mole fraction of solute is number of moles of solute divided by total number of moles of all the components, where N2 is the number of moles of solute and N1 is the number of moles of solvent. How to find out the number of moles? Mass divided by molar mass. Clear? Suppose if W2 gram of solute of molecular mass M2, if W2 gram of solute of molecular mass M2 is added or is adding to W1 gram of solvent of molecular mass M1, of molecular mass M1. Clear? How to define the number of moles? How to calculate N2 as number of moles of solute? Means what? Mass of the solute how much? W2 gram. What is the mass of molar mass of a solute? M2. Number of moles of solvent, mass of solvent W1 divided by molecular mass of solvent M1. Very simple. N2 is equal to W2 divided by M2 is mass of solute and molecular mass of solute, mass of solvent and molecular mass of solvent. Next, P naught minus P divided by P naught N2 W2 divided by M2 and W1 divided by M1 plus W2 divided by M2. Suppose you have to know that the dilute solution and the concentration solution. Clear? Raoult's law is applicable only for dilute solution. You have to study in this chapter only for the dilute solution, not concentrated solution. The dilute solution means the number of moles of a solute is very less compared to the number of moles of a solvent. Hence, the number of moles of a solute in the denominator can be neglected because what? The solution is dilute. Because solution is dilute, number of moles of solute N2 is very less than N1. Hence N2 can be neglected. ಅವಾಗ ಏನಾಗುತ್ತೆ ನೋಡಿ ಇಲ್ಲಿ P naught minus P divided by P naught is equal to W2 divided by M2. ಇಲ್ಲಿ ನೀವು N2 ನ ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ W2 W2 divided by W2 divided by M2 can be neglected. ಅವಾಗ ಏನು ಮಾಡ್ತೀರಾ, ಈ whole term becomes is a neglected into ಮೇಲ್ಗಡೆ ಉಲ್ಟಾಗುತ್ತೆ ನೋಡಿ M1 divided by W1. ಓಕೆನಾ? ಏನು ಮಾಡ್ತೀರಾ ನೋಡಿ, this implies P naught minus P divided by P naught is equal to W2 into M1 divided by M1 into W1. This is equal to P naught minus P into M2 W1 is equal to P naught into W2 into M1. Suppose in this equation you have to write it as M2 is equal to P naught W2 into M1 divided by P naught minus P into W1. This is an important formula for calculation of a numerical problem where M2 is molar mass or molecular mass of a non-volatile solute, P naught vapor pressure of the pure solvent, W2 indicates what? Mass of solute. M1 is equal to what? Molecular mass of solvent. P naught minus P indicates what? Vapor pressure of the solution. W1 is the mass of the solvent. Suppose in this the colligative property relative lowering of vapor pressure, in your board exam you have to ask the numerical problem based on these formula. Calculate the molecular mass of a non-volatile and non-electrolyte solute. All the values are given. You have to calculate only M2 first written as a formula and substitute, and the final answer with unit gram per mole. That's very important. Okay na? Next some important numerical problem. ಅದಕ್ಕೆ ಹೇಳ್ತಾರೆ first the concept, basic concept what? Lowering of vapor pressure ನೀಟಾಗಿ ಗೊತ್ತಿದ್ರೆ the relative lowering of vapor pressure is very simple. This is a very important formula for the numerical problems in your board exam for asked for 3 marks. Clear? Okay, let us consider the first numerical problems on your relative lowering of vapor pressure. Clear? Suppose in your solution chapter in your board exam, the one numerical problems in your all 4 colligative properties. ಒಂದಂತೂ ಇದ್ದೇ ಇರುತ್ತಪ್ಪ. ಓಕೆನಾ? Let us consider the first problem. Vapor pressure of a pure benzene. Vapor pressure of a pure benzene at a certain temperature. The vapor pressure of a pure benzene at a certain temperature is 640 mm, means millimeter of mercury. 640 mmHg when 2.17 gram of a non-volatile solute is added to 39 gram of benzene. The vapor pressure of solution was found to be 600 millimeter of mercury. Calculate molar mass of a solute. ಇದರ ಅರ್ಥ ನೋಡಿ ಇಷ್ಟೇನೆ. ಸಪೋಸ್ ಒಂದು ಪ್ಯೂರ್ ಸಾಲ್ವೆಂಟ್ ಇದೆ, ಆ ಬೆಂಜಿನ್ ಆದ ಸಾಲ್ವೆಂಟ್, ಅದಕ್ಕೆ ಏನು ಮಾಡ್ತೀರಾ ನೀವು 2.17 ಗ್ರಾಮ್ ಆಫ್ ಸೊಲ್ಯೂಟ್ನ ನೀವು ಹಾರ್ಡ್ ಮಾಡಿಬಿಟ್ಟಿರ್ತೀರ. ಸಪೋಸ್ ಹಾರ್ಡ್ ಮಾಡಿದ್ರೆ ವಾಟ್ ಹ್ಯಾಪನ್? ದ ವೇಪರ್ ಪ್ರೆಷರ್ ಇಸ್ ಡಿಕ್ರೀಸಸ್ ಫ್ರಮ್ 640 mm to 600 mmHg. You have to find out what is the molecular mass of your volatile solute. Let us consider the given data. Given first, P naught means what? Vapor pressure of a pure solvent. In this case, what is the solvent? Benzene. Nodi, the vapor pressure of the pure benzene is equal to how much? 640 mmHg. Next, another one point. What is the vapor pressure of a solution? Means clear. The vapor pressure of the solution is how much? 600 millimeter of mercury. You have to understand one point. The vapor pressure of solution is always less than the vapor pressure of the pure solvent. Adu nimge gottirabeku. Adu very basic concept. Clear? ನೀವೇನಾದ್ರು ಉಲ್ಟಾ ಬರ್ಕೊಂಡ್ರೆ wrong. Vapor pressure of the solution is always the less than the vapor pressure of pure solvent. That's very important. Next, you have to add how many grams of your non-volatile solute? W2. The mass of solute how much? 2.17 gram. 2.17 gram of solute out added that 39 gram of benzene indicates what? Solvent. W1 is the mass of the solvent, 39 gram. Clear? You have to find out M2. M2 is equal to how much? This is the formula. P0 is given, P is given, W2 is given, W1 given. You have to find out the M1. M1 is equal to what? Molecular mass of solvent. Solvent means benzene. What is the molecular formula for benzene? C6H6. The atomic mass of an carbon 12 into 6 plus hydrogen 6 into 1. You get a 78 gram per mole. ಕೆಲವೊಂದು ಟೈಮ್ನಲ್ಲಿ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್ ಆಫ್ ಬೆನ್ಸಿನ್ ಅವರೇನೋ ಕೊಟ್ಟಿರ್ತಾರಪ್ಪ, ಕೊಡದೇ ಇದ್ರು ಯಾವ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಬೈ ಯೂಸಿಂಗ್ ದ ಫಾರ್ಮುಲಾ C6H6 the 78 gram. Suppose the substitute P0 is equal to how much? 640 into W2 indicates what? Mass of solute 2.17. M1 indicates what? Molecular mass of solvent. The benzene is 78 gram per mole. 78 divided by P0 640 minus P, vapor pressure of solution 600 into W1 indicates what? Mass of solvent 39 gram. Are you understand? Clear? All data are given. This is equal to the multiply this one, they give us 108576 divided by the multiply this one 1560. The final answer is 69.6 gram per mole. This is the your molecular mass of a non-volatile solute. Suppose in board exam the formula, correct formula 1 marks. And the substitution, suppose you don't write the gram per mole, you have to lose the 1 marks. That's very important. So unit is a gram per mole, the molecular mass of a non-volatile solute. In your board exam, just you have to change the vapor pressure of the pure solvent and solution and solvent. Clear? Solvent ಬೇರೆ ಯಾವುದು ಮೆಥಡ್ಸ್ ಎಲ್ಲ ಒಂದೇ. P0 P ಎಲ್ಲ ಅವರೇ ಕೊಟ್ಟಿರ್ತಾರೆ. ಕೆಲವೊಂದು ಟೈಮಲ್ಲಿ ದ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್ ಆಫ್ ಎನ್ ಸಾಲ್ವೆಂಟ್ ಅವರೇ ಕೊಟ್ಟಿರ್ತಾರೆ. ಸಪೋಸ್ ಕೆಲವೊಂದು ಕೊಡದೇ ಇದ್ರು ಬೆಂಜಿನ್ ಕೊಟ್ಟರೆ ಯು ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ದ 78 gram. You have to understand the first problems. Okay, let us consider the second numerical problem. The vapor pressure of pure benzene at a certain temperature is 0.850 bar, means the barometer. Let us consider what is the given P0, means what is indicates the vapor pressure of pure benzene. What P0? 0.850 bar, comma 0.5 gram of non-volatile non-electrolyte solute. 0.5 gram non-volatile solute means is W2. W2 is equal to how much? 0.5 gram. 0.5 gram of non-volatile non-electrolyte solute is added to how many grams of benzene? 39. Means the mass of solvent is equal to how much? 39 gram. Mass of solvent means benzene. Bracket il avare kottidare ನೋಡಿ 70 molecular mass of benzene is equal to how much? 78 is called M1. Molecular mass of solvent 78 gram per mole. The vapor pressure of the solution means P. P is equal to what? 0.845 barometer. The vapor pressure of solution is less than the vapor pressure of the pure solvent. You have to find out the molecular mass of a non-volatile solute. Given data ಗೊತ್ತಾಗಿದೆ ತಾನೆ? Clear? You have to understand? Next, write down the formula. M2 molecular mass of non-volatile solute is equal to P naught into W2 into M1 divided by P naught minus P into W1. Substitute M2 is equal to P naught is equal to how much? 0.85 into W2 means what? Mass of a non-volatile solute 0.5 into M1 indicates what? Molecular mass of a solvent 78 divided by P naught 0.850 minus P indicates what? Vapor pressure of the solution 0.845 into W1. The mass of the solvent is a 39 gram. This is equal to, we have to simplify 171 gram per mole. I have to simplify this. I have to simplify separate target. You have to simplify this one. You get 171 gram per mole. These are the molecular mass of a non-volatile solute. You have to correct answer ನೀವು ಬರೆದ್ರೆ the final exam you have to get 3 out of 3 marks. The numerical problems is very important. Clear? My dear student, I hope all are understand. In the next session, you have to study the another colligative properties. Okay?